Recently, a question came up on the Fusion 360 forum that led me to this YouTube video. And I'm going to back this up a little bit and watch a little bit of the video.
Of that process, right? So knowing the type of sheet metal and what the bend radii would be.
And so, you know, pick a bend radius. It might be related to the sheet metal part, the thickness of the sheet metal part, so forth. But I'm going to continue on. You can do it the same way that he did it, but that's not the way I'm going to do it.
Radii. And now the next step is I want to be able to shell that out. Right, so now I'm going to make that, let's say, 100 thousandths thick. So I have a 10 gauge, 100 thousandths thick. And what's cool is it's shelled to the bottom, right? And if I hold Control and I click the bottom, it shells all the way through.
Now this is all wrong. Shell will not give you the correct sheet metal geometry. It just isn't right. And so let's look at the correct way of modeling a sheet metal part like this. So I have the same starting geometry that was demonstrated in the video, but for demonstration purposes I'm going to increase this fillet to a lot larger size so that we can see clearly why it wasn't modeled correctly as a sheet metal part, and then I'll put it back to the 0.25. So I'll go ahead and I'll do the shell the same as was done in the video. But I'm going to make that shell thickness really thick, let's say 0.75. And I'll say OK to that. Now notice when I do this shell that this face right here is horizontal and this face right here is horizontal. But in a sheet metal part, that is not the properties of sheet metal. Sheet metal, when the flat pattern, this face is the edge is cut perpendicular to this face. So right now this face isn't perpendicular to that one, and it should be. So that's why shell is not the correct way of doing this. So I'm going to undo that, and I'm going to do it in a different way. And again, we can change that fillet back to a smaller size. I think I'll do that later. I could put my rip along here. I could, and if I were going to, I would do the sketch on this plane, or I could or not put a fillet in one corner the way the original presenter did, and then put the rip in that corner. But I'm going to put the rip along here because I like symmetry, and I'm going to assume this part will look better with symmetry. And so I'm going to find the appropriate sketch, and I'll do a new on the appropriate plane. I'll do a new sketch, and I'm going to project this edge right here onto the sketch. Now it might be easier to see if I turn off that solid body for a minute so that we can see how I'm going to do the rip. I like to change this line to construction line in case later on I make a change that would cause that to go sick. My entire sketch doesn't go sick. So then I'll draw my own line over top of that, and I'll draw a line from here, and I'm going to go down. I would like for it to be parallel to that line. Notice it puts that parallel constraint between those, and I'll put these two coincident, and then I'm going to go ahead and dimension the distance between those two lines. And I'm going to make it extra wide for now, and so that you'll clearly be able to see what I'm doing, and then later on I will change that. So let's turn on this solid body again, and this time I'm going to use a hybrid technique which will give us the correct sheet metal part. And so I'm going to go to the Surface tab, and I'm going to delete, rather than shell, I'm going to delete this face, and I'm going to delete that face. Right, and then I'm going to do a trim. I'm going to select this sketch as my trimming tool, and I'm going to remove this area right in here for my rip. So there's my rip. I'll hide the sketch, and then I'm going to do a new sketch on this face, and so I'll do a new sketch, and I will P for project geometry. I'll select that face, and I projected that entire face. I'll finish that sketch. I'll go to my sheet metal and I'll make my first sheet metal flange. And you would need to select your correct rules, thickness for the sheet metal, so forth, and decide whether your dimensions were to the inside or the outside. I'm going to flip this around so the given dimensions to the outside of the part, and I'll say OK to that. And so now I have my flange body for sheet metal, and then I'll go back to the surfacing tools, and I'm going to do thicken. And I'm going to thicken this. Now our thickness is 2.5 millimeters for the sheet metal rule. Change that to whatever's needed. And I'm going to select this surface body, and I'm going to go minus then the 2.5 millimeters to take that towards the inside, and I want to join that to the original flange. Now let's go back to his video for a minute and look and see, you know, what how that was accomplished in the original video.
That it has an open tangent edge, right? So the next thing I want to do is I want to learn earlier in the beginning of I want to apply that trick we just learned earlier in the beginning of our live 360 live today, is being able to turn this into a sheet metal part from a solid body. So that's why I'm going to grab this edge right here, and I'm going to put a sketch on there. And it seems like it's a bit of a long way around, but at least it's a way that we can get there, right? So
watching the video, he's right about that. It was a long way around, and the results just aren't right. You know, they're not correct. If we look at this, we see now that this edge is perpendicular to this face. It isn't horizontal anymore. In the same way on the bottom, this edge is no longer horizontal. It's now perpendicular to this face, and see how it comes around the arcs here. And so that's a correct sheet metal part. And if the way to check to see that original idea was incorrect is if you go to the flat pattern, and if you go to a wireframe view, you would see double lines here where there should only be one line where this edge is perpendicular to the flat. And so that's a quick, easy way to test it. And so now if I want to go back and change this, you know, if I want to change that fillet back to the way it was presented originally, I could put that fillet, and then if I want to decrease this rip to close up that gap, I could edit that sketch, and let's change that to, let's say, 0.001, and I'll finish that sketch. And so now I have a real small rip along this edge. It would be easy to solder or weld that seam up, and it all looks nice and symmetrical. And if we go to our flat pattern, you know, we get our flat pattern. So that is the correct way to do a problem such as this. And then when he continues on to a cone, it gets even more painful to watch.